Okay, I'm just gonna start while others are joining. Okay, so today we are going to do that number 9 or chapter 9. Let me just share the I wanna share the screen. Okay, so question one is saying a large city hospital conducted a study investigating the relationship between the number of unauthorized days that employees are absent per year and the distance in kilometers between home and work for the employees. A sample of 10 employees was selected and the following data was collected. So you are given data on distance to work in kilometers, which is X, and the number of days absent. Okay. So they're asking you to develop a least square estimated regression equation line that relates to distance to work to the number of days absent. Okay, let me just switch off my video so the internet can be stable. Okay, so here they're asking you to develop a least regression equation, the estimated regression equation line that relates to the distance to work to the number of days absent. Okay. I need to remove this. Okay, so what they're asking you is actually the equation y is equal to a plus bx. Okay, so that's the regression equation line that they want you to find. But for us to find that regression line, we need to know the formulas, the formula of A and the formula of B, how to find A and B. Okay, so first of all, before you do anything, you have to find the values. So you are only given the values for X, given values for X and the value for Y. Okay, and you need to find what is XY, you need to find X squared and Y squared. You need to find the mean and the mean of X and the mean of Y. Okay, so, but our main goal, remember, is to find the regression line. The regression line equation is this one that is found here. That's what we want to find. We want to find this line. So this one, the first one, 8.01 is our A and 0.2139 is our B. That's what we want to find. But for us to find A, we need to know what the formula for A. So the formula for A is Y bar minus bx bar. Y bar is the mean and x bar is the is the mean for y bar is the mean for y, and the x bar is the mean for x. Okay, can everyone mute themselves, please? It's making noise. Please make sure your mic is muted. Okay, thank you. Oh, so our A, the formulas are already said. This is the formula for finding A. We want to find this line here, these values, how I found these values. So first I must find A. Our A is y bar minus bx bar, which is the means. Okay. So y mean is actually just the mean of the value that is given. So here you are given your y here. Here's your y. This column here. Sorry. This column here is the y. All right. So all you need is to find the mean of y, is to add all these numbers. We can actually just add them here. It's just to add 3 plus, I don't know if you can see the calculator. I don't think it's gonna show. Okay, so 3 plus 5 plus 4 plus 8 plus 8 plus 2 plus 7 plus 6 plus 5 plus 2 divided by the total number. So the total number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you divide by the total number, you find your y bar. Okay. So that's the y bar that is given here. Okay. And your x bar is the same. You have to find the mean of x, which is just adding up these numbers here, all these numbers under x, divided by 10. That will be your mean x bar. Now we have to find our b, because they say you must find the regression line. So you find your y bar, which is this, and your x bar. And for us to find b, we need to use this formula. This is the sum of squares of xy divided by sum of square of x. Okay, so what do we mean by sum of square? The sum of square is the same as this formula. It's just that it's the sum of x. So the sum of square is the sum of xy minus the sum of x times the sum of y divided by n, which is our 10. The sum of xy is basically what is given here. You just multiply these two. So if you already found, the first thing you must draw this diagram and find the values. The sum of xy is actually adding up all this, the sum of xy. Okay. So here is the sum of xy, which is 144.84 times 50. Times 50 is actually the sum of x times the sum of y. The sum of x is just the total number of what is here if you add all this, times what you will get if you add all that. All right. Okay, so the answer is 144 times 50 over n. The n is the total number of the variables. Okay. That's what you find here for your sum of square of x, y. But remember, this is the formula for our b is sum of x squared, xy divided by sum of squares of x. So the sum of squares of x, this is the formula. So you need to know these formulas. If you don't know them, then you can't solve. Please, can you, I don't know who's speaking, but please mute yourself, guys. Can someone mute themselves? Can you make sure your mic is muted, please? Okay, thank you. Okay, so now the sum of squares of x is basically this. The formula is just you square the numbers of the values of x and you add them up. And this one is just you sum the number of x, and then the total you square it. It's not this one, it's different from this one. So you should know, you just punch in, you find your values, and that's the answer there, all right? So then our B will be the sum of squares of xy divided by the sum of squares of x here. And that's the answer, okay? And our equation, you just substitute what you found there and you put it there. But the first thing you must find is B, because you use B to find the value of A, because you need B here to find the value of, you need B to find the value of A. All right, okay? So I just explain what the values are. Any question? Okay, so let's go to question 2. So that's how you find the estimated regression equation line. So basically it's just a matter of just finding the values of this and your mean and the sum of the square, and knowing the formulas, knowing the formula of what is A and what is B, the formula of A and B, and also knowing what consists of those formulas. So what is the sum of sum of squares of xy, and what is the sum of squares of xy, what is the formula? Then you just substitute it. It's very easy. If you know the formulas, this chapter, these questions are very easy. Okay, so let's go to question 2. Question 2 said interpret the least regression equation. So they're basically just asking you, what did you find there? What is it telling us? Okay. So this is what we found there. It's basically it's the regression line. They're asking you what that really means. Okay. So let me just hold on for a second. Okay. So what this regression line really means is just saying that for every 1 unit increase in the distance to work, so if x is 1, all right, let me just scroll up. So if x is 1, it means that there will be a decrease of 0.2139, okay? And that decrease is the decrease in the number of days absent. So remember, what is our y? Our y was number of days, okay? So we are interpreting, we want to interpret this. So what we are saying, that if there's an increase of 1 here in the distance to work, or 1 kilometer, there will be a decrease. Why is a decrease? Because the value here, you can see the value here is negative. So there will be a decrease in the number of days absent. So what actually means is that the estimated intercept, this intercept is 8.0981, indicates that when x is equal to 0, for example, if the distance is 0, then the number of days absent will be exactly 8. So if x is 0, the number of days absent will be exactly 8. If x is 1, it means that there will be a decrease in the number of days of negative 0.2139. All right. Any question? All right. So question C is saying predicted the number of days absent, predicted the number of days absent for an employee who lives 9.1 kilometers from the hospital. So they're just basically giving you what they're giving you kilometers, they're giving you X, right? They give you X here, all right? And they are telling you, can you predict? Okay, guys, please mute yourself. Okay, so they are saying that predicted the number of days absent for an employee who lives. So they're asking you to predict the number of days for an employee who lives 9.8 kilometers. So they basically just give you X. You already have your regression line. So all you need is just substitute where there's X, you put your number. Okay, so you have your line there. You just put where there's X here, you put your 9.8 days. All right. So you are given, so if X is equal to 9.1, then Y will be, you just substitute where there was X, you put 9. That will be 6 days. All right. Okay. So question D says calculate and interpret the correlation coefficient. Okay, before I start with correlation coefficient, do you guys have any question? Any question? Okay. I can see in the chat saying no. All right, thank you. So I'm just gonna continue. Question D says, calculate and interpret the correlation coefficient. Okay, so the correlation coefficient has also its formula. The formula is the sum of squares of xy divided by the square root of sum of squares of x times the sum of squares of y. That's the formula for correlation coefficient. So I'm just gonna show you now. Okay, here is the formula for correlation coefficient. Okay, the sum of squares of xy divided by the square root of sum of squares of x times sum of squares of y. The sum of squares of xy we already found it. So all we need is just to take it down. Sum of squares of xy, here is sum of squares of xy, and it was negative 1.52.89. So just take that down. Okay, here it is, right? And the sum of squares of x and the sum of squares of y is also, we already found the answers. Sum of squares of y was 714.7114, and the sum of squares of y was 46. So it's just a matter of just multiplying these two here, okay, and you find your answer. But then the question is, you need to interpret what you found, okay? So basically this just means there's a strong correlation. There's a strong negative correlation. Why it's negative? Because you have a negative value, okay? If it was a positive value, you would say that there's a strong positive correlation between the distance to work and the number of days absent. But there is a negative correlation, meaning if the other one is up, the other one is down, okay? And that correlation is very strong, okay? If it was 0.5, anything from 0.4, it means that it's not strong. There's a weak correlation, okay? Anything from 0.5 upwards is a strong correlation. Okay, so any questions so far? So these questions are very easy, guys. So all you need is just to know the formulas. And they are the same questions. They'll ask you the same questions on this topic. That's what they're gonna ask you, nothing else. There's nothing like a tricky question. Okay, so question A is saying that calculate and interpret the coefficient of determination. So again, the coefficient of determination is basically it's just the square root. It's a square of the correlation. So the correlation here, the square is the coefficient of determination. Okay. Let me check in the chart. Yes, say, mom, can you show us to use stats on the calculator? I have to make a video on that, but I can show you to use Excel if you're gonna use it. If you're gonna use if it's a question comes on that, you can use Excel. Excel is very quick. But I'll make a video on a calculator as well. But for now, question 2, I'm gonna show you how to use Excel. Excel is gonna be very easy for you guys. You can, but I'll make a video for how to use it on calculator. All right. But I'll show you the Excel one in the next question. So calculate and interpret coefficient of determination, as I've said, is just the square root of correlation coefficient. It's just square, not square root. It's the square of the correlation coefficient. So what you found here is just, here is what you found. You just square it. It's the coefficient of determination. So basically what it means is just the variation in the number of days absent is being reduced by the percentage that you found here. You can say it's being reduced by 71%. So what it means that if we take a distance, if we take a distance to work, it will be reduced by 71%. The number of days absent will be reduced by 71%. All right. Okay, so let's go to question 2. Question 2 says, the medical researchers have noted that adolescent females are much more likely to deliver low-weight babies than adult females. Because low-weight babies have higher mortality rates, a number of studies have examined the relationship between the birth weight and the mother's age for babies born to young mothers. One such study's results are recorded below. So you have maternity age and the birth weight of babies. Okay, so the same questions as I have told you on this chapter, the questions will be the same. All right, there will be nothing you will be nice. So you just have to practice this, especially having a quiz tomorrow. If you just practice this thing, I think the whole on chapter 9 you'll be able to understand. Okay. So calculate the least square regression line, the same question. So I just want to show you how to do it on Excel. So these are the values that, okay. Let me share my Excel. Okay. Okay, so these are the values that we are given. Then all you need is to find the, so to save your time, I'll say use Excel. If you can open 2 browsers, you copy your values in the Excel, and then you find what is your XY. You just multiply. So you say equals 15 multiplied by that. That's your number. And then you just press here. You hold the other key on your laptop, the first key, you hold it, and you push this line down. It means that it's using the formula for all of them. So you found the answers. Then you go to the second question, you say equals, I want x squared. So I want this number, and then I just square it. You say shift on your PC and the hashtag on top, and you put your 2, you say equals, okay. That's your answer. And then you hold your first key on your laptop and you scroll this down. It's applying to all. The formula is gonna apply to everything, the remaining of the variables. Okay. And you do the same for y. You say equals y. You say shift. You put to the power, to the power 2 equals the same. You hold your first key on your laptop and you scroll this down. So you scroll, meaning, yeah, okay, so you have your values. Of these values are correct. Okay, and then I want x times, so then I want this x multiply by that. Okay, and then I put the values down. It's just telling the thing that you must apply the same formula to all of that. And that you find the mean of x. The mean of x is just average. You say equals average of x. So here is our x. Okay, 17 is our mean. So mean is just the same all over. So I can't scroll down. And the mean of y is just equals mean of y average. Y, okay, equals, okay, that's our mean. And then I find the totals, all right? The sum of something. So I'll just put sum there. I found the sum of that, because that. I can also just scroll this up to say the same formula must apply to all of them. Okay, so it's gonna sum up. Okay, so here you have your total. Okay, there's some problem here. Yeah, it's just showing that the number is too big, so just leave it. All right, or we can do it manually and just say sum sum these numbers. All right, cool. Okay, so we have all our figures. Let me see if this thing is all right. Yes, it's fine. All right, so these are our totals. All right, we have our totals there. Then you can find you can try to answer your questions. Okay, I did it slowly just because I'm trying to teach you guys, but I'll do it more quicker. If I was writing exams, I'll do it more quicker. So then you have all your answers. I don't know what's happening to my case. All right, so these are our totals. And then all you need to do is just go back to the questions. So all these totals, you find the sum of squares, the sum of square of x, the sum of square of xy is this, the sum of squares of y is this, the sum of squares of x is this. You have xy squared, the sum, or everything is there. Your mean of x, and then you just you go back to, so I'm gonna stop sharing this. You go back to your question and you just punch in your answers into the formulas. So they are saying calculate the least square regression line. Okay. So here remember our x mean was 170. Remember our x bar was 301. So all these numbers is what was found there. Okay. You can even check, verify later, because now or we can say our x was 70. We can check all these numbers. You'll find that they are they are here on our Excel. Remember our mean was 17. Our mean of X was 301. All these numbers, you see 551, 600, 29, 10. You'll find them there, right? Okay, so then you find, then the same question, all you need to do now is just punch in. So you want the line Y, so you want this line, okay? Y is equal to A plus B XY. So you just punch in the numbers, you find the values. So you have to know the formulas again, know the formulas. All right. Okay, so, and then the second question is saying, what would be predicted birth weight of a baby born to 18-year-old? So your regression lines, so now they're giving you the number of birth weight. Birth weight is Y. They're giving you Y now. They're not giving you X. Remember in the previous question, it was X. Now they're giving you Y. I understand. They give you 18. So you have to know what they are giving you here. Okay. Know what you are being given. Okay. So you just substitute in your equation. Here you put Y. Okay. Sorry, they didn't give you, sorry, they give you 18 as X, right? Yes, the weight of a baby. What would be the predicted birth weight of a baby born to 18 old? Yes, 18 old mother, sorry. 18 old mother, they're not, sorry. It's the birth weight of a baby that they're asking you. So 18 weight is X, all right? So you just punch in, they may give you Y, they may not give you X. So you have to know what they're giving you. And then you just put in the formula that you found here, you just put it in, okay? Okay, so now we have, the other question is saying calculate and interpret correlation coefficient. Again, correlation coefficient is just the formula here. And if you drew that question on Excel, you would know what these values are, what these values mean. So you just punch in. Okay. And then our correlation is 0.8837. Okay. So can someone tell me what does this mean? The correlation of 0.888. So our correlation, let me just stop sharing. All right. Yeah. So okay, so here our correlation is 0.8. So what is our interpretation there? What do you think? What will be the interpretation? Anyone? So it's 0.88 something. So what will be interpretation? How do you interpret this? Anyone? It's a strong, yes, Mzuki, see? Yes, a strong positive correlation. Yes, all right. So there is a strong positive correlation between the weight of the baby and the age. All right. So it means that if the age is up, the weight also goes up. That's like you can reason that is true. Okay. So what will be our coefficient determination? What would be our R squared? Coefficient determination. The last question is saying calculate and interpret coefficient determination. So what would be our coefficient determination? So remember our thing was 0.837. Anyone? Our coefficient determination will be what? Anyone, what will be our coefficient determination? Yes, it's just a square root. All right, correct. Okay. It will be the square root of that. All right. So it will be just 8837. You square that, you square this. That's your answer. Okay. And that should be what the lady, but because I gave you only 0.8, but this is basically the answer will be 0.7809. Okay, so that's the answer. And what this means that there's a variation in the birth weight is being reduced by approximately 78% if we take the mother's age into account. So you just multiply that by 100, okay? So what it means is that the variation in the birth weight is being reduced by approximately 78% if we take the mother's age into account. All right? Okay, that's it. So any question? If there is no any question, that should be the end of our task today. So all I can say is just practice this question for your quiz. Just practice these questions. I don't know if your quiz is multiple choice. I don't think it's multiple choice. I think it's regulations. I'm not sure. So you guys, can you tell me when can I have to discuss your assignments? So give me the dates so I can teach you, except on the first. I can't do it on the first. So tell me when I can teach you